Simulink from MathWorks is a tool for model-based software development. Today I'd like to show you how you can easily and quickly integrate Simulink models into the control program of your SIMATIC controller. To demonstrate, I've brought along a basic Simulink model for you. It consists of a PID controller with its controller parameters, P, I, and D components, and a PT3 control loop. You can easily simulate and visualize the behavior of the controller and the loop in Simulink by using a scope, for example. All you need to do is click on the play button. Simulink calculates the behavior of your entire control loop. After you've verified the behavior of your control loop with Simulink, you can integrate the controller into your controller program. Again, to demonstrate, I brought along a basic model for you. It only contains the PID controller. This model has 3 inputs and outputs. The inputs are for the set point value and the process variable. The outputs correspond to the control variable. In order to launch the whole thing on the SIMATIC controller, you need to select the relevant system target file in the model settings. Here we'll select the area code generation. And now you can see the system target file. Currently, the Simulink coder is selected as the target. Once you've installed the SIMATIC Target 1500S, you'll be able to directly access it as a system target file in the selection dialog. And now I can perform various model settings. For example, I can activate the external mode. With the external mode, you can observe process values from your user program directly in Simulink. For this purpose, I change to the interface area and select the external mode. All I have to do now is to input the matching IP address of my controller. It's 192.168.101.15. I also have target-specific options in the Area Target 1500S options. Here, for example, you can activate parameter access from your S7 program. This allows you to have direct access to model parameters from within the user program and to change them during operation. To generate the code for the model, I simply click on the button Build Model. The SIMATIC Target 1500S now creates C code via the Simulink coder. This C code generates modules that you can integrate directly into your user program. Let's proceed to the generated files via the Outputs link. There you'll find 2 files. First, an SCL source that you can import into the TIA portal, and second, a so-called SO file that you can upload via your controller's web server. To do this, I switch over to the TIA portal, where I've already prepared a project. It contains an ET200SP open controller. In this open controller, you'll find a couple of I/O modules as well as the software controller and an HMI runtime. You'll find exactly the same thing here in my demo case, the ET200SP open controller with I/O modules. Above you can see a screen that displays the Windows desktop of the open controller. Apparently, the software controller is running in the run operating state now. In the next step, I'll import the SCL source. First, I'll switch to the software controller, open the folder External Source Files. From there, I'll choose the generated SCL source. After I've imported the SCL source, I just have to generate the modules. Once the modules have been generated, I can integrate them into my user program. The controller is normally launched in a cyclical program. Therefore, I've already prepared a cycle OB in the 100 millisecond cycle. Here you'll find the simulation of the control loop, and I'll now insert my module for the Simulink model. The generated module has the same name as my Simulink model, along with a supplement of 1 step. Using drag and drop, I drag the module into the cycle OB, confirm the creation of a new instance DB, and I can now connect the module to the process parameters. For simplicity, I've stored the process parameters in a database. I can see a parallel view of both editors, so that I can simply connect my process parameters with the model module using drag and drop. The set point value, the process value, my control variable, and the status of my module. To use the external mode, it's necessary to insert a separate module into the program. This has the same name as my model, PID model, and then call xmode. I also move this module into my cyclical OB using drag and drop, confirm the creation of an instance DB, and now I just have to activate the external mode, either via a variable or hard-coded. Now I can load the user program into the controller. To do this, I click on the Download button. Now the program is compiled and can be loaded into the controller. By going online into the controller, I can check at the same time whether my download was successful and whether I can establish an online connection to the controller. As you can see, the entire program has been loaded into the controller. Next, I still need to load the SO file into the Open Controller. This is performed via the Open Controller's web server. This occurs in the web browser via the CPU's web server. For this operation, I switch to the file browser, where I select my SO file in subfolder ODK1500S and upload it. This caches the SO file in the CPU. By means of a stop-start transition on the controller, the SO file is loaded into the RAM of the controller and is therefore directly executed. I can also see this in the TIA portal by activating the monitoring function in my cycle OB. This lets me see the values of my process variables in the module editor. I can also have these process values displayed in Simulink. To do this, I switch to the model, open the scope, and now I simply activate external mode in the function connect to target. This lets me also see the process values in the Simulink scope from the controller. To give you a more in-depth view, I could also connect to a setup step in the TIA portal. I move the TIA portal a bit to the side and use the function control variables, and I set the setpoint value to 80, for example. When I do this, I can immediately see in the scope how the setpoint changes to 80 and the control variable increases accordingly. But I can also change parameters right in the Simulink model. To do this, I switch over here into the PID controller. I'll illustrate this based on the upper control variable threshold by lowering the parameter from 100 to 30 in this example. Then I can immediately see in the scope how the control variable decreases to the value of 30. On my controller module in the controller, the control variable has also decreased to 30. In order for my controller to revert back to the desired settings, I set the value back to 100. And this allows my controller to operate in the way that I originally designed it. Naturally, I can also have the process values displayed directly on the Open Controller by launching the HMI, which is installed on the Open Controller. For demonstration purposes, I've inserted a trend control that displays the process values in real time directly on the screen. So you can see how easy it is with the Target 1500S to integrate Simulink models into an S7 program. With no C++ or ODK expertise, you can now utilize model-based software development with Simulink and SIMATIC.